was going to talk a little bit about propeller vibration and vibration reduction. My name is Matthew Dock with DynaVibe. A little bit of background, I am a pilot mechanic, AMP, also engineering background, but I really enjoy flying. I love the old antiques and experimentals. I used to have a 150 straight tail and a 172 straight tail. Right now I've got a Cessna 210, a Long Easy, and a Kit Fox on floats. So I like to have a little, you know, every plane has a mission, so you got to kind of fill in all the spots, I guess. We're going to talk about propeller balancing, vibration reduction. A lot of this is covered in AC 2037. So it's advisory circular on propeller maintenance, how to paint the prop, how to finish the prop, how to statically balance, etc. We'll talk about some terminology, causes for vibration, the effects that vibration causes, you know, what happens, detection, correction, and then some examples. So AC 2037 talks about design damage and failures, maintenance and overhaul, accessories and balancing, and installation. So static balance, a lot of people will say, well, my prop's balanced at the factory. Static balancing is performed by the manufacturer or an appropriately rated station, a repair station. Dynamically balancing a prop repairs any paint, putting the propeller on. Anytime you put the prop on, if it's off by tenths of a thousandth, you're going to wind up getting a vibration. So you normally want to dynamically balance, or at least check it to make sure it's not too far out. 70% of the time, it's halfway to the FAA limit. So I'll talk a little bit about that. We have the magnitude of the vibration. When we're doing this analysis, you're going to hear us talking about inches per second. That's the magnitude of the vibration. 0 inches per second is perfect. 1.2 is actually the FAA limit. So we kind of operate in that 0 to 1.2. If you have a 1.2 vibration, you're supposed to pull the propeller off, send it off to a repair station and have it repaired. Instances of that, we actually had a 172 that the blade had a mid-span twist. So if you measured the blade pitch at the tips, it was fine. But if you kind of sighted down the trailing edge of the blade, you could actually see it had a twist in it in the mid-span, and it always came out at like a 1.2, so we had to pull it off, send it off to the repair station, gave them instructions to check the mid-span pitch, not just at the tips. They were able to repair that, return it, and then it flew great after that.
How does something like that happen?
I'm assuming it got twisted and then someone repaired it by just retwisting the tip. So, you know, the repair station, we've had issues too where a propeller was really bad. We sent it back to the repair station and they go, oh, the weight that we have assigned to blade 3 actually goes on blade 2. So, I mean, everybody makes mistakes. I think that can happen. Because we found on that particular prop that all the weight was offset of the weight that they put on. So it's like, well, this weight's exactly in the wrong spot. It's really weird. Send it in. So there are a lot of things that can happen in that regard. So this is just an ISO standard. So vibration in the machining industry and industry is pretty widespread. So these principles of, you know, 0.2 IPS, you start to feel it. 1 IPS is pretty bad. 1.2 is going to cause a lot of damage. It's fairly common to use those in our RPM ranges. So one of the things we'll talk about is the frequency of the vibration. The propeller for a straight driven engine without a gearbox is going to rotate it once per revolution. So the crank and the prop all spin at the same rate. But there are other vibrations. So one of the things we'll see when we're doing the test run later is there's a thing called a half per, which is every other rotation. That's actually cylinder firing. So if you have a weak cylinder, there'll be a vibration at the half purr. The 1 purr is, of course, the propeller and the crank. A 2 purr, we'll see this on a 2-bladed propeller. As the blades pass near the ground, you actually get a thump-thump twice per rotation. So we can tell if it's a 2-bladed prop or a 3-bladed prop. 85% of the time, it's a simple 1 purr vibration. So we'll have a guy that'll say, oh, I balanced my prop, but I still have a vibration. That's pretty rare. That's 15% of the time. 85% of the time, if there's a vibration, it's because the prop needs to be dynamically balanced. So what causes the vibration? It's almost always a mass error. So either due to a repair or paint or the position of the blade, there'll be a mass error that once you start spinning, it's going to cause that vibration. The front of the engine's going to kick up and down. There is also an aerodynamic error. I mentioned the Cessna 172 that had the mid-span pitch variation. That will cause more lift on that blade, and it will tend to change with RPM. So as you go up in RPM, that aerodynamic error increases. So what we'll hear customers say is, well, I balanced the prop at 2200, but at 2400, the vibration comes back. That kind of tells us that it's probably coupled in to an aerodynamic vibration, and there's ways to check for that. And then, of course, cylinder power differences, accessory problems, combustion impulses, magnetos. There's a whole host of, after you've checked the prop for mass imbalance, then you check it for aerodynamic imbalance, and if there's still a problem, then things get complicated. You have to get into the details of why that engine prop combination may have a vibration. So I don't know, I guess that doesn't play. So this is an interesting cause. This is actually, in this video, if it were to play, the spinner is actually looks crooked. But every time you stop, it looks straight. So what we found is that if you pull the spinner off and lay it on the table, it would roll to one side, and it had a heavy spot in it. Then you get to looking inside, somebody had put fiberglass in there. So they had repaired it, but they hadn't balanced it. Well, once you put it on here, it would, every time you start the engine, it would find a new home. And so what we saw on our vibration analyzer was that you couldn't ever get a steady phase. It would never pick a spot. Well, as we got to looking, the spinner backplate was actually cracked because that offset weight inside of the spinner had flexed the backplate so much, it had cracked that. So essentially you got to pull all that off, and then it balanced fine, and everything went well. This is another one. Customer complains that every time he runs the balancer, he gets a different number. Well, there's a crack propagating through here headed to this bolt. And so what was happening is you could actually see that the gap would open and close, and that causes the mass error to kind of move around. So that was interesting. So this is another one on kind of the manufacturing, maintenance, repair. We actually had a customer that had this issue where at 2100 it was really smooth. Up in cruise, it had a bad vibration. Actually took 2 photos. You know, you pull the plugs out, set up a camera, take a picture, rotate it, take another picture, and you actually see that the 2 blades have a different shape to them. Wow. So it had either been repaired or had some sort of process that made the 2 blades different on each side. You can see the small deviation in the shape, which generates an aerodynamic imbalance, which you can fix with weight at any 1 RPM. Is there a question?
So, since we can't see the whole thing, was that a constant speed drop?
That's fixed pitch.
Fixed pitch. So, you get to the point where you had a different shape on the 2 sides.
It had to have been a repair. Somebody decided to go in and repair this blade, and they probably filed down the leading edge, took a couple of nicks out, then sanded it down. We don't want to have the nick there, right? So they probably sanded it down and then repainted it. That's the only way I can see how they would get a completely different shape. So this is another one where you can see how much they've fixed the tip. Somebody's filed the tip off a little bit. So what happens then is the two blades have completely different vortices coming off, right? So you can imagine that this thing's out there flailing around. And then other issues, moisture and corrosion. Obviously for wood props, moisture is a huge problem. I'm from Oklahoma, actually Stillwater. We have really good humidity there, if by good I mean high. In Wisconsin, I flew my Long Easy up there for about 3 weeks, left it in Wisconsin, and noticed a vibration the first flight after having it up there, and went and retorqued all the prop bolts, and they were about half of what they should have been. Had to get a torque wrench, retorque everything. The dry weather in Wisconsin had allowed the prop to shrink, and I didn't have proper compression, and so the prop was essentially back there chattering a little bit.
So by extension then, do they go for a torque when you got back in the humidity, loosen it up?
No, because you always take the prop bolts off, right? So I wouldn't have even noticed if it had. So every 25 hours on a wood prop, I take off the safety wire, loosen all the bolts, and then retorque them back to spec, and then re-safety wire. And it's a real pain, and it's just part of the process, because I've been burned by...
Half hour to do that?
Yeah, and if you're doing it, part of an oil change, it's just, you just do it all at once.
I think Stinson says 25 hours.
25? Yeah. Yeah, it's pretty scary. On the front face of this propeller, I actually had it serviced by the manufacturer because I could see char marks. So when the prop bolts get loose, the prop starts fretting, starts rocking back and forth, and it'll actually start charring the front face, and then you lose compression even faster. So, anyway. Engine motor imbalance. A lot of times, as planes get older, the isolators will get hard, and somebody will say, I've had this plane for 10 years, and I've got 400 hours on it. It just seems like it's not as smooth as it used to be. Some of that could be isolators. So what does vibration cause? I mean, if you've got this vibration, part of it is it goes to the power of the vibration level. So if you've got small ball bearings or surfaces that are interfacing with each other, a 10x increase in the load, 10x increase in the vibration is 1,000 times decrease in fatigue life. So if you take something and start moving it very small, the typical coat hanger problem, that little vibration over time will cause fatigue cracks. We see this a lot where, engine cowlings, fasteners around exhausts, significant, 54% reduction in vibration if you do corrective maintenance and prevent that, then a lot of this work goes away. So exhaust cracks, this is my old Cessna 150. I flew it all over. I took it to the Bahamas, to Catalina Island. I was flying over the mountains once and started getting a headache, neck pain, your vision starts constricting. I'm like, I'm supposed to be at 9,000, but I'm at 8,500. Why is this happening? So I opened all the windows up, stuck my head out the window, and then I could hear a beeping sound, which was my carbon monoxide detector going off. Well, what had happened is this exhaust had cracked, and on the Cessnas, the fresh air vent of this model is right behind the exhaust. So when the exhaust cracks, it pumps the exhaust straight into the cabin. So at 8,500 feet, I was getting hypoxic, having this confusion of, what's occurring. and was able to get it repaired and back in service. Another big one is pilot comfort. A lot of this is for helicopter guys. If you want to know if you have a vibration, you can really let your body tell you. If you put your hands out for this high frequency 2400 RPM, 40 hertz vibration, that high frequency is usually felt in things like the fingers and toes. So a lot of times our customers will say, well, I can feel it in the rudder pedals. Well, that's because your toes are really light. So if you just take your finger and kind of work around the panel, you'll feel that buzz. That's usually a bad propeller. If you kind of feel it in the seat of your pants at a lower RPM, like you're going over ripples in the road, that's usually a cylinder because it's a lower frequency. The helicopter guys usually feel it in their back just because the rotor RPM on a helicopter is lower. It has a vertical motion. They usually feel it kind of in their torso. So you can usually get an idea of the frequency by how you feel that vibration. Okay, so how do we fix it? I mean, vibration's bad. It's going to cause fatigue cracks, pilot fatigue, maintenance problems, but how do we fix it? So we're going to show this here in a little bit. We have an accelerometer that we mount on the engine, usually as close to the crank prop flange as we can. We also mount a photo tack that's looking for a piece of tape. So the accelerometer is going to measure that orbital motion of the engine as it's fighting that mass that's out there spinning. We warm up the engine. The system gives you the RPM, which is great to check the instruments. My Kit Fox has an electric tachometer, and every time the beacon fires, the tach goes down. So you know it's wrong because it's based on system voltage. Well, you can always check it using this system, which is completely separate. It gives you the magnitude of the vibration, 0.88 IPS, how bad is it, and the location of the heavy spot. So that's really the magic, because it tells you at what point in the rotation is there a bad, aerodynamic imbalance or mass imbalance. So we run the engine, pull the data, 0.88 IPS. We realign the blade with the photo tack. So here's the photo tack. We look for that piece of tape. So we're going to align the blade back with the photo tack. And then when we do that, we leave the prop in that position and go 258 degrees in the direction of rotation for this example. So essentially 90, 180, 270 would be over here, 258. That's the heavy spot, so it's telling you where it's heavy. You could take weight off, but normally what we do is just add a washer to the opposite side. So we add weight, usually to the spinner back plate, or starter on a light combing starter ring. Add that weight, usually 2 or 3 cycles in order to do it. Just like balancing tires, you're going to add a weight offset that makes it run a lot smoother. So then we run it again. 0.06 IPS, 313. Normally we want to be definitely below 0.2. That's where most of the manufacturers for propellers and exhausts say that you should finish. It's below 0.2. I like to try and get it below 0.1, but there's always things that could affect that. The closer you get to 0, the better, but kind of 0.1 to 0.2 is a very good job, especially if you start off at 0.88 like this was. This is just kind of showing that if it doesn't work the way it's supposed to, there's probably a problem. You have to start looking. That's the crack I was talking about, the spinner that I mentioned with cracks in the spinner back plate, which allows everything to kind of move around. So this is what we call the DynaVibe Classic. It only shows you how to fix the 1 per vibration. 85% of the time it's the 1 per, it's the propeller. The DynaVibe Classic will allow you to fix that. I'm going to talk more about the GX, which is what we're going to show today. It is a more advanced system that allows you to look at those other frequencies I talked about, the 0.5 per, the 1.5, 2, 2.5, 3. It works a little bit differently, and we'll show this out there. You essentially set it up graphically for each particular case, put in the information for the owner of the aircraft, and then it's actually going to tell you exactly how much weight and where to put it. So you tell it how many screws you have on the spinner, and it will tell you which bolt to put it on and how much weight. This is spectrum analysis. So what this does is breaks down all the vibration based on the frequency and the magnitude. So it also has this H1, 2, 3. So this corresponds to the order of the vibration. The 1 is the 1 per, so it's rotating once per crank/prop speed. And the magnitude 0.25, so that spike says that this propeller has a 0.25 1 per vibration. It has another vibration at 2.15. So this is, the prop is really what we want to look at. The 2 per on the long easy is actually because it's a two-bladed prop with a two-bladed wing, you could say. There's a wing in front of the propeller, and every time the propeller passes behind that wing, I get a thump thump. So there's 2 pulses per rotation. The really only way to fix that is to improve the airflow attachment of the wing so that the prop always has nice clean air that it's flying through. Much more challenging to get rid of these. That's actually the alternator, 2.6. Yeah, prop out of balance. If you have a cylinder combustion issue, you can see here it doesn't. This is actually pull a plug, pull the magneto to the plug, and then switch that magneto off. You get a really high half per. That's essentially showing you that it's not a prop problem, it's a cylinder problem. So this is.
I'm sorry, what about constructing destructive interference? So if you get something that's a 1 per and something that's a 2 per, is that already factored into the one?
It will show up as additional spikes. So there's amplitude modulation, which we see very, very rarely, and it's usually because something's binding up. You'll get what's an amplitude modulation, and it will show up as little shoulders on the side, and this may have a very small hint of it, but these little shoulders on each side of the peak. Normally you'll also get a beat frequency, which this system will separate out the beat frequencies into individual bins. And so it can get pretty complicated if you have a high compression engine, 6 cylinders, you're almost in the realm of pinging. If the engine's really hot, you'll get all these little harmonics. We can see all that, but it does get more complicated once you get into those situations. So somebody mentioned Jim Beatty, not Beatty, Jim out of Wichita. Yes, sorry, thank you. There was a lot of discussion about these half VWs, that they vibrate really bad, there's nothing you can do about it. So I went up to Jim's and we hooked it up to his half VW engine. I get this Spectra, which you can see the largest spike is a 1 per. It's like, hey Jim, this doesn't look bad, we ought to be able to make this really smooth. Let's start putting some weight on. And what we found is that these half-cut VWs, they weld an additional flange on the side of the prop flange as a counterweight. Well, they'd overestimated that. So we wound up putting a big weight opposite of that. We make the 1 per go away, and then Jim was like, oh, I can see all my instruments now. This is amazing. So that's that case. This is a float plane out of Nashua, New Hampshire. This aircraft was interesting. The customer was complaining that I've got a really bad vibration in the floorboard. So we actually put the balancer in the cockpit first and flew around and figured out what frequency it was. Then we put the accelerometers on the left and right engine. And in one case, so these are geared, which is interesting. This is the crank speed, and then this is the half per crank. So you can tell that there's a large spike on the half per crank, which tells us, because it's half of the crank speed, that it's a cylinder. So we said, hey, there's a cylinder issue here, we need to dig into it. We did a bore scope inspection, found a burn valve. We were able to track that down. Now, I said, look, this is interesting. On the other side, it's a totally different problem. There's this large 1.5 per crank. So does anybody know when you have a 1.5 per vibration on a 6-cylinder, what that means? It's literally half of the engine is not running as well as the other half. So this was actually a weak magneto, and doing a magneto check, it shows up. He's like, oh yeah, I've always had that problem that magneto drops more. Okay, well it's to the point where it's actually misfiring on one side. So that whole bank of cylinders had an intermittent misfire. This is another one, cam. Someone was talking about cam corrosion or cam damage. I feel your pain. This is actually a customer's engine that had cam failure, and once the cams get flat, you get a half per, because it's just not lifting as much. I mean, once it gets so bad, the engine just doesn't run well on that cylinder, and you wind up getting this half per. We actually had a case in the 210. We just had the engine rebuilt. A customer had put on an oil pan heater, plugged it in, and our estimate is about a month that they'd left it plugged in, and it totally wiped out the engine. So we had to have the engine torn down because of a cam failure. We had low compression on the cylinder. We look in the cylinder, it's all scratched up. We pull the cylinder. Underneath that is a big piece of the cam missing, a lot of corrosion. We tear that down, and then we notice that all the corrosion had single specks on it. So it was one event. The guy had left the oil pan heater on one time, and that had caused condensation that then pitted the whole engine. Now, so be careful with that this winter. We also have TotalVibe. A lot of guys that are doing eVTOL craft use this in order to determine resonance when the engine is at its worst vibrational magnitude. And tips, FAA AC 2037, I talked about that. Verify bolt torque, 25 hours oil change, talked about that. 1.2 IPS, go ahead and pull it and send it to the shop. And then just typical problems, fiberglass back plates, unbalanced spinners. Blade pitch errors are probably not a big concern for most fixed pitch guys that we have seen it. This really comes up a lot in experimental where they've got these ground adjustable props that are eyeballed. They get yeah, that looks about right. That's a big problem. And then blade tracking. You can find a lot just by doing the blade tracking test where you spin it through with the plugs out and check that the tip is within 1/16 of an inch. Helicopter stuff, if anybody has any questions on that. So I think that puts us back on time.
Yeah, and if you want to follow up after we do the...
Yeah, if there's...
when we run it.
Right.
And come back in and just do a follow-up if you want to do that.
My thought is I'll talk about it while we're running it, and then if there's any questions, we can do it then, and then get you guys back on schedule. Any questions?
This is great.
Thank you.
I got one. So how easy is your system to, and I may be jumping ahead, but for just the average person to be able to set this up and do it itself?
I tell people it's going to take you an hour, first time you use it, to figure out where everything goes. Most mechanics can do it in 15 minutes, so it's very simple. I think every mechanic ought to have a system, put it on, just to check it. You don't even have to, don't charge people for it, just check. And it's probably going to be out of balance, and then you can have the discussion with the customer about, this is where we're at, here's where we are in the limit between 0 and 1.2, and if we want to do a corrective action, then it's usually shop rate. But for someone that owns a plane or has a couple of planes, it's very easy to learn to do.
Have you seen the deals that bolt on behind the propeller that are like a hydraulic ring? What are your thoughts on those?
So I think if you have a really bad vibration, let's say you're up at 1 IPS and you want to take it to a 0.5, maybe that's an option. Most of the people we work with, like Voodoo, Reno Racers, they really want to dial it in. So the way those systems work is you have to have a vibration for the mercury or the liquid to know where to go, right? So it's never going to get you down to 0. Usually it's about half.
So it'll make bad okay, but it won't make okay excellent.
Right.
Gotcha.
It's Band-Aid, it's not fixing it.
It's a Band-Aid, right? You know, I've actually got one from a long time ago, and when I actually ran measurements on it, you know, the fact that it only takes that about half out, and if you get really down below 0.2, since it's sloshing around, since it doesn't have a vibration, it actually makes it worse. So it's a Band-Aid.
So if you have, like, if you're using primarily like washers as weights or something like that, do you have alternative weight systems that you can use as well? So the propeller I have does not have bolts, it has a big Jesus nut right down the center.
Right.
And there is a spinner that goes around the outside, even the spin, about the only way you can do it, you can put it under the head and screw on the spinner.
Right.
And I just don't know if that's going to
Yeah, so Advisory Circular 2037 kind of shows a couple of different ways, and that is weight on the back plate. They usually want the bolt and shear, but you can put weights on the back side of nuts. If you have a bolt that comes through the outside and you want to put weight on it and then mount the back of that, you can see a lot of those examples in AC 2037. Some of the old, like a skull cap spinner on a small one, Cessna 150, it can be a challenge. We'll actually wind up doing it with spray paint. You just hit it with a little extra paint on one blade, and that'll fix it. Because all you're trying to do is correct for that mass imbalance. Now, if it's offset, you know, if it's a chord-wise error on a two-bladed prop, that can be a challenge. You just kind of have to look at every case. That's one of the things, we've seen a lot of these. So if somebody has a DynaVibe and they want to balance something tricky, just call us. We're always available to help.
Did you find that reclocking the propeller changes the dynamic?
You know, there's been a lot of debate on that on the internet, and there is a case where that could apply because, say, on the Cessna 210, the nearest cylinder is got a shorter path, and on the IO 470s we see a lot of crank twist, so the back cylinders don't behave the same way as the one next to the prop. So there are cases where that helps. I would say it's few and far between, but there are cases where the correct prop clocking is critical. Warm up and everything. All right, everybody, I'm going to talk a little bit about the DynaVibe and setting up the system. When you load it up, there's a lot of little menus. Using is called auto balance. That way it'll automatically calculate the weight based on the first run. There'll be 2 runs. So one of the things that's unique about the DynaVibe is you get to pick if you're on the pilot side or the mechanic side. So I'm on the mechanic side, and I'm setting up where I put the accelerometer. I mounted the accelerometer just behind the front of the starter ring vertically, and so it graphically has that on here. So it's got the wire pointing out the top. It's a 2-bladed propeller, so you tell it it's got 2 blades. The photo tack is on the right side. You see the photo tack here. While I'm looking at it, just graphically shows me photo tack on the right. I put in 12 holes. So there are 10 screws around the outside, obviously missing for where the blades are, but there are 12 holes essentially symmetrically around the spinner. And then I told it that when it's in this position, that this one on top is number 1. So it's going to let me know exactly which screw to put it under. So I want to have kind of that consistent numbering scheme. So I've got all that in. Have to tell it the direction of rotation. You know, it's always a little different for certified and experimental aircraft. So I get all that loaded, and then I hit accept, and now it's ready to run. So obviously on the first run up. We're going to want to warm the engine a little bit so that we're not running it at full RPM cold. So I think we're ready.
All right. All right, clear prop. I don't know what that is.
Okay, so we were showing 2300 there at first, and then that last little bit, 2440. I think that matches pretty well with what you were seeing on the actual tach, so pretty close at the high end. I got a 0.6 IPS at 267 degrees, so it is about halfway to the FAA limit. I'm going to hit adjust on here, and it is suggesting 24 grams on bolt 4. So what we'll do is we've got to have the appropriate weight. We've got to weight. 24 is a lot of weight. So these are 4.5. I don't know if I have. Well, we'll start with this. We'll run this and get the improvement. Normally, we'd want to put a washer on the back plate. The limit is 35 grams, but it's going to be a heck of a stack. So let's go ahead and verify that mags are off. Double check for me.
Mags are off.
Mags are off. So I'm going to position the photo tack so it's in line with the tape. I've got a light on here. And I'm going to hold this up. There's actually a button that you click that says show, and it's going to highlight where to add the weight. So this is position 1, and even though it's rotating counterclockwise, the numbering on the DynaVibe GX is actually in the direction of clockwise. So it's saying to add the weight to bolt 4, which would be right here. So it's indicating that this blade is light, and what we're going to do is add weight to the nearest location. The weight at position 4, I was asking for 24 grams. Now, we can't do exactly what it wants, so what we're going to do is tell it exactly what we did. So this is the most important part. Regardless of what it asks for, I'm going to tell it that at position 3, that's this screw, bolt number for addition, position 3, I put on 12, so it's 4 times 3, 12, 13.5 grams. So I want to put in the exact numbers. And then at position 5, so 1, 2, 3, 4, 5, at position 5, I put on 2 washers, and that is 9 grams. So it's going to learn from the first run to the second run what the correct amount of weight is. So that's why we have to tell it exactly how much. All right, we're ready to do it again.
So we're going to take it up to
24, 2440, that exact same.
You were 0.6 on the first run.
0.6 on the first run.
No, we're driving.
I know what it is. All right, clear.
Clear. Okay, so on that run it was 0.26 IPS, and it's asked for more weight on bolt 5. So it wants another washer on bolt 5. So 1, 2, 3, this is 4 that we can't use. This is 5. So let's add a washer to bolt 5.
Okay.
Yesterday you screwed up, but today you did good.
Yeah, I don't know.
Okay, so for the third run, we're now at 0.13. So, you know, 0 is perfect. 1.2 FAA limit. We started at 0.6. We went to a 0.26, and now we're at a 0.13.
Cut it in half again.
If we wanted to continue down the road, we would add additional weight. For me, 0.13 is a really good starting point. And one of the things you'll want to do is move the weight to the back plate and run it again. And that's not something we'll be able to do today. But going from a 0.6 to a 0.13, when you fly it, you should feel a difference. That should be a pretty substantial improvement in the vibration level. So I've saved the report, and I'll email that to Brett and let him forward it on to you. The report will be a complete showing every step we took, the finish, where the weights are, what the final value is. It will also include the spectrum. That's the spectrum I was talking about inside with the half per, 1 per, 2 per. Now, if we wanted to see the spectrum right now, we could do one more run, record it so that we can talk about that. Would that be okay?
Sure.
So let's run it one more time just to get the spectrum so we can show it on the display.